The force P. The force P, caused by the ship's permanent magnetism, acts in the vessel's fore and aft line. If the force P is in line with the Earth's magnetic field, it has no deviating effect. But if it is not in line, it deflects the compass needle. Therefore, the deviating effect of the force P varies with the vessel's course. It is considered positive if it acts towards the bow, stem. The illustration describes the effect of the force P. It is positive force if it is acting towards the bow, and negative if acting towards the stern. As shown in the animation, the deflection of the compass needle varies as the sign of the magnetic. The force Q. The force Q, caused by the ship's permanent magnetism, acts in the vessel's athwartship's line. If the force Q is in line with the Earth's magnetic field, it has no deviating effect. But if it is not in line, it deflects the compass. Therefore, the deviating effect of the force Q varies with the vessel's course. The illustration describes the effect of the force Q. It is positive force if it is acting to starboard, and negative to port. As shown in the animation, the deflection of the compass needle varies as the cosine of the magnetic course. The force O. An illustration of the effect of the force O is shown in this animation. Is the combined effect of the forces P and Q on the vessel's compass. If the force is in line with the Earth's magnetic field, that has no deviating effect. However, if it is not in line, it will deflect the magnetic needle. The A-rod causes an induced magnetic effect, as though the soft iron is lying in the F and A line. Usually on a vessel, it is a effect. Its strength varies with latitude and the vessel's course being maximum at the equator on quadrantial 45-degree courses. The strength of this rod is indicated by the line AB. When the vessel is heading north magnetic, the A-rod is induced to the maximum. When the vessel alters course, the strength of the rod reduces by cosine of the magnetic course, as indicated by the line BC. The line BC has a deviating effect equal to the line CE, which varies as sine of twice the magnetic course. The animation shows how the effect of the A-rod varies with change in heading. Please note that the effect of H varies with latitude. H is maximum at the equator. The deviating effect varies as sine of twice the magnetic course. The E-rod causes an induced effect as though the soft iron is lying in the athwartship's line. Usually, most vessels have a negative E effect. Its strength varies with latitude and the vessel's course being maximum at the equator on quadrantial 45-degree courses. This animation shows the induction of the E-rod with change in heading. When the vessel is heading north magnetic, the E-rod is not induced. However, when the vessel changes heading, the induction on the E-rod increases. This increase is shown by the line BC and is equal to AB sine theta, where AB is the value of force H. The deviating effect of this force is the line EC, which varies as the sine of 2 theta. However, the effect of the E-rod on a compass is opposite to the effect of the negative A-rod. The deviating effect varies as sine of twice the magnetic course. The C-rod causes an effect as though a piece of soft iron were placed either directly forward or abaft the compass. On modern ships, we normally have most of the body of a vessel aft and below the compass. Therefore, negative C is normal in the northern hemisphere and vice versa in the southern hemisphere. The effect of the C-rod is maximum at the poles and 0 at the equator. These animations illustrate the change in induction of the C-rod with change in latitude and its deviating effect on the compass. The C-rod has a maximum deviating effect on easterly and westerly courses, and no deviating effect on northerly and southerly courses. Deviating effect of the C-rod in the northern and southern hemisphere.